everyone, I'm Dr. Sonali and I welcome you all to CSE Core Concepts in the series Data Science with Python. So basically in this video, I am going to deal with the naive-Bayes classifier. Regarding the theoretical part of this algorithm, that is naive-Bayes, I have already discussed it and it is in my playlist for machine learning course. And the implementation of this algorithm is also available in RStudio. So here in this video, we are going to implement this algorithm using the Python. Now, regarding this algorithm, what we need to do is that we have to first take our admission data set. So instead of we have already discussed about it, and I will again show you here how does the admission data set looks like. So let us first begin by importing some of the important libraries. We do not know about the classifier libraries as of now. So I'm just going to use the regular NumPy, Pandas and the Matplotlib library. Now I'm going to mount my Google Colab because I have already saved my data file in Google Drive, and I need to mount it. I need to mount Colab with the drive. So this is going to be done. Now let me consider the data set, that is pd.readcsv file, and the location of my file is content. I will show you how does the data set looks like, my drive, and the admission underscore data.csv, right? So let us have a look at the data set here for now. So let data set dot head, let us first see the first 5 some records, right? Okay, so let us see. Okay, so we have 4 columns here. One is admit. This is just the indexing. Okay, the first column, just ignore it. We have 4 columns: admit, GRE, GPA and rank. Okay, now admit is something the target one. Okay, so whether the student will get admission or not, that depends on the GRE, GPA and his rank. GRE score, GPA score and the rank. Now what you can see from this data, first of all, these are your X values, GRE, GPA and rank, and admit is the target. That's okay, that sometimes target is at the first or at the end, that is not a problem. But one more feature, you should, whenever a data is given to you, you should analyze to figure out what can be done before you can apply the algorithm. You can see, observe here that the GRE scores are the values 380, 660 and so on. And the range of GPA is what? 3.61, 3.67. So what we need to do here is that we need to scale our features, right? Because we want them in the same range, right? Whereas rank is in the values of 314 and like that, right? So of course we will do feature scaling, and about what is feature scaling, I have already made a video on that. You can go through that video in the model training part. Okay, so let us now once we know our data, so now let us have some idea about some of the data types, some of the features of the data set, like your D types. Let us see the data types of them. Let us see the data set dot index, that how many data values are there. Data set dot columns you can see, and data set dot values. Values, some of them we have seen. Let us have again a look of it. So these are our 4 columns. Admit is integer. Only GPA is in floating, rest all are integers. And how many data are there? So some 400 records are there, right? And the values are in this range. Fine. So now I hope you are clear about the data. So once you are clear about the data, let us say X is equals to data set dot ILOC. So what are you going to, we are going to use all the rows, that is fine. But regarding the columns, you want to have which columns here? Your 0th column is your admit, first is GRE, second is GPA, third is rank. So we want the first, second and the third column. Okay, that's it. We don't want the last column. And Y is equals to, you can write down Y data set dot admit. Directly you can write. Now what let us see the shape of our okay, fine, that's what we have assigned as for now. Okay, now let us split our data set into the training and the testing part, right? So if you want to split your data set, so you are going to use sklearn dot model underscore selection, import, train, test, split, right? This we have been using a couple of times in my previous videos also, so you might be aware of it. So what am I going to get from here? I will get the training data from the X values, the testing data of the X values, then Y target values for training, target values for testing. This I will get by calling the train, test, split function, and the arguments I have to give the whole set of X values which will be splitted into training and testing. Similarly, I have to give the whole test set of Y values which will be again splitted into training and testing. Test size I have to give, let's say I am giving 0.2, that means 20% is my testing data, 80% is my training data, and I want some randomness in my data, so let me say 20. So this is what it is. Now let us view the shape of our data, right? So you can see print X train dot shape and X test dot shape. Let us see the shape. How does it how does it look like? So my training set contains 320 rows with 3 columns, and the testing contains 80 rows with the 3 columns, right? So total I had some 400 records. So 80 records are for testing and 320 are for training. This is what we have set as of initial. If we are not happy with the accuracy value, we can of course later change it on, right? Now, as I told you, by looking at the data, the ranges of the data of each column is different. So here we need to do some feature scaling. So for doing feature scaling, we need to import the standard scaler from sklearn. So from sklearn.preprocessing, I am going to import standard scaler, right? And the X values only, not the Y values, right? So I have to create an instance. I have to instantiate the method. So I am calling this SC, and I have to do it for both the training as well as the testing data, right? So I will say X train is equals to SC dot fit transform, and the same data I am not putting. Sometimes you may even you want to preserve the X train, Y train. So in that case, you can take these values in some other variables. That is also fine. But here, since we are not interested in doing so, preserving, so that's fine. I can change it in that same variable also, right? Okay. So this is my X test and Y test, which I have done the scaling. Now, after doing the feature scaling, let us call the model, okay, and try to create the model. Now what we are going to do here is the calling the naive Bayes classifier. So for using the naive Bayes classifier, again from the sklearn dot naive Bayes method, underscore Bayes method, I have to import the Gaussian NB module. Understood? So otherwise I cannot use the naive Bayes classifier. So let me give a name of the classifier. So what name we can give? Okay, let us first instantiate it. So what name we are going to admission classifier, right? Admit underscore classifier. What we are doing is equals to Gaussian NB, right? Then we can say admit underscore class dot fit. So I have to give the training data for fitting my model, that is in X train and Y train, right? So let us see if my model is being created. Yes, my model has been created. Now how my model is performing, that we need to see. So now when I have finished training or teaching, I need to do some testing by giving some Y prediction is equals to, let me call my model admit underscore classifier model, and I will give the question paper, that is our X test. Now we will not be able to figure out, because if I just press it like this, it will write, I have to write dot predict class. I forgot to call this function. Yeah, so now it is 0, 0, 1, 0. Now can you find out from your all 80 records that how many are correct, and are you going to match it? No, let us give this work to the to Python only, right? So now what we are going to do, we are going to find out, evaluate, right, the model by based on its accuracy score, confusion matrix, maybe a classification report. Okay, so this all we require. So to use all those, we have to import the sklearn dot metrics. What we are going to import, accuracy score. You want to see the accuracy score. You want to create a confusion matrix, and you also want to display the confusion matrix display, right? This is all what you want. So let us use the accuracy score is equals to accuracy underscore score, which will be computed based on the testing data, that is answer key, and the predicted values from the model. So let us have a good formatted print of it. So let us write down F accuracy score is, and you can use the curly brackets, so you can write down, let us round it off, otherwise it will go to 5 or 10 decimal places. So we can say round accuracy multiplied by 100, I want it in percentage, into 2, and let me say in percentage. Okay, so let us see the accuracy score. So it is 68.75 accuracy I am getting, right? So what is the misclassification error? If I want to print the misclassification, that is 100 minus accuracy will give you, but still if you want to print it, you can write down misclassification error is, and in the curly brackets. Now here you have to use the round function, but the round function will be used on what? 1 minus accuracy. Okay, that will be multiplied by 100 in comma 2, right? So this is how you have to show it. So there will be 2 curly brackets. Please be careful about the brackets, otherwise you will get an error. Right. So the misclassification error is 31.25%. So it's quite high. We need to tune our model. So to understand that, let's see what is the problem. So let us create a confusion matrix. So CM is equals to confusion, confusion underscore matrix, which will be created by y test comma y predicted. We are not going to directly print confusion matrix because we have already discussed that it is very difficult to understand without any head labels. So let us say confusion matrix display. We will use some good methods of displaying. So confusion matrix display. So we will write down confusion. We have created already. Matrix is equals to CM, and display labels. Which labels you want? The classifier admit underscore class, the y test. Okay, the testing data which was there. So you can say y test dot unique names. Okay, you do not want to be repeated. Okay, fine, right. So this is done. So let us, we want to plot, display our plot. So this dot plot. Now let us give some good color values, which is better. Otherwise you can even omit this. Then by default it can take some colors, right? Dot cm dot blues. Maybe blue is my favorite color. Okay, so plt dot title. Let's give a good title, that is confusion matrix, and let us now say plt dot show. Okay, so you can see a good confusion matrix. Now these are the true labels, these are the predicted labels. So the diagonal elements are the corrected ones. So 46 of them belonged to class 0 and they are predicted as 0. But 16 were actually belonging to class 1, but they have been predicted to belong to class 0. Here 9 are actually, they belong to class 0 but are predicted as 1, and 9 here are actually belongs to class 1 and they are predicted as class 1. Okay, so how many are total? 46 plus 9, that is 55 are correct out of 80. 80 test data was there. So you have almost, so 55. So you have almost 25 incorrect results, right? You have a 25. So that is not a very good way So what you can do is that maybe the model is not able to learn properly. So in that case, you can even, or sometimes a overfitted model. I have discussed about what is underfitting and overfitting. So let us keep the ratio 70-30. Okay, so if you keep the ratio 70-30, maybe it can do well. I do not know. Okay, then you can increase the randomness of the model. Now, also it is possible that all the features are not important for it to be shown, right? So now you can see what is the accuracy. It has increased to 71.67 when I had increased the testing size. Now, sometimes it may happen that all these three features are not contributing very greatly to the model performance, right? So you can even perform trial and testing on them. Like if I do not want, maybe GRE and GPA score are more important for getting admission. If rank is not there, let's try. I do not know. So let us remove the rank. Okay, we are not considering rank. So we are only considering GRE and GPA. Then you have to recreate the model. If you are changing the parameter, you have to recreate. Again, I have kept 70-30 as the ratio. It is just a trial. Let us see how is it working. Again, it dropped. That means rank was playing an important role, right? So let us, you can even do this type of trial and testing. You remove GPA score. Okay, you just keep GRE and rank. Okay, so otherwise, if you don't find any difference, then maybe that was the highest one which you could get, right? The accuracy. So let us see, accuracy is 70. So it at least it has increased. That means rank was playing a prominent role. Understood? So this way what you can do is that you can even try with many combinations. Like let us not consider the GRE score. Let us only consider the GP and the rank, because we saw that when we tried to remove rank, it dropped drastically, right? So that way also you can even try out. Okay, otherwise you can find out. Yeah, so 75%. I think this is the highest one which is we are getting, right? So you can try with different parameters. Even you can change the training testing split also. Okay, maybe this is not sufficient. You can go for 75-25%, or you can go for some 60-40. Okay, so various permutations and combinations you can try and tune these hyperparameters so as to get a good accuracy of the model. Maybe you can increase the randomness of the model also, right? So this work you need to do to figure out. See, it is good, right? 73%, but not that good. That was giving you the best one, right? Here I have used all three of them. So you can tune on these hyperparameters to, this is called as performance tuning, to get the good accuracy metrics, right? And which is mostly misclassified, that you also have to check. Okay, this one. So mostly those which are 1, they are misjudged as 0. Right? So this is a clear reflection of how it is working. You can even print the classification report if you want to, right? So you can just say that print classification. I think I have not included it. Classification underscore report, right? So if you see the classification report, when I have included, you can just print it, classification underscore report of Y. Just a minute. Yes, classification report of Y test and Y predicted. Understood? So you can see the precision, recall, support. So accuracy is 68%, weighted average. All this is being given, right? So where it is failing, you can even find it out. So this is, I hope you understood about this video. If you want to implement in RStudio, that tutorial is also available. And if you want to understand about the naive based classifier, that is a probability based classifier, go through the theory. I will share the link in the comment section as well as in the description box. Don't forget to like, share and subscribe to this channel. Stay tuned. We are going to come up with more such machine learning algorithms. Thank you.